Hello, welcome. We are in Chapter 1, FST, and in this chapter we're going to be looking at a lot of statistics. So today we're just going to start talking about some basic tables and graphs, specifically two types of graphs that will include bar graphs and circle graphs, also known as pie charts. First, though, we do want to talk about a few variables or a few vocabulary words that help us kind of set a foundation for the work that we're going to do in statistics. So since we're spending a chapter learning about statistics, statistics is a type of math that involves collecting, organizing, analyzing, and interpreting information. Now, in this class, we won't spend too much time focusing on the collecting of information. If you were to take a college level statistics class, you might do some collection methods. We will spend a lot of time organizing our information. That's going to be through different tables or graphs, so being able to decide which graph might best represent our data. And then analyzing, interpreting. So then being able to look at a graph and decide, what is this graph telling us? What can we learn about this information or the things that we were studying? Now, that information is what we're going to call data. So data is numerical information used in statistics. So that's typically numbers. Maybe that information is your GPA or the amount of hours you work or your income or your age or things like that. All of that we're going to refer to as data. Now, as we're kind of looking at these different situations, there's three things that we're going to want to be able to identify. The first is a variable. Now, we've seen variables in math before. Typically, those are letters like X and Y, but in statistics context, a variable is going to be what is being studied. Another way to think about this is the question being asked. This is often the number. So this is like, if I ask you, how many hours a week do you work? That's a question being asked. That's my variable. That's what I'm trying to study. Or does this new medicine help you lose weight? Your weight would be what we're studying, how many pounds, etc. So the variable is what is being studied or the question being asked. The population is going to be who is being studied. And the key with the population is this is going to be the entire group. Now, this is going to be different from the sample. If we think about what the word sample means, sample is a piece or a part. If you get a sample of ice cream, it's just a little taste. Or if you get a sample of paint to put on your wall, it's just a little bit of paint. So a sample is a piece or a part of the population. That is actually studied. So often for the sample, I'll ask who or what did we actually ask the question to? Now, I'll give you an example of that really quickly, and then we'll take a look at some examples below. For example, an election, right? A lot of polls will try to predict which candidate is going to win the presidency. The question or the variable would be which candidate is going to win. That's what we're trying to study. Which person is going to become president. Now, the population in the United States would be every eligible voter in the United States. That's who we're trying to predict that information about. But it wouldn't be realistic for us to call everybody in the United States. So we're going to take a piece or a part of the population. Maybe we call 1,000 people in Michigan, and 1,000 people in Texas, and 1,000 people in North Dakota, and 1,000 people in New Jersey. And we ask them, who are you going to vote for? So we'll just take a piece or a part, and that's what we would call the sample. Now, it would be best practice that our sample is randomly chosen. We wouldn't want to only ask people in Michigan who they're going to vote for, because that might not represent the whole United States, right? We know that states tend to lean more Democratic or Republican, so we would want a fair sampling of all the states, not just people in one state, to try to predict who's going to win the presidency in the whole United States. So to be randomly chosen means that everyone in the population has the same chance of being selected for the sample. And the reason we would do this is this helps eliminate bias. All right, we'll take a look at just a couple examples here of being able to identify those three different things. So looking for the variable, looking for the population, looking for the sample. In example A, 100 juniors are surveyed to determine the most popular fast food restaurant among students at Jenison High School. Now, if I were to go to students at Jenison High School, the variable or the question that I'm asking is, what's your favorite fast food restaurant? That's what we're trying to determine. That would be the question that's being asked. So the most popular fast food restaurant would be our variable. Now, who we're trying to know that about, the population is the whole group, where a sample is just a piece or a part. What we're trying to find is the most popular fast food restaurant among students at Jenison. The whole population that we're studying would be students at Jenison. But it wouldn't be realistic for me to ask every single student at Jenison High School. Even though there's only about 1,500 students, that would still take me a long time, and being able to track everybody down would be difficult. So the piece of Jenison that we actually asked would be the 100 juniors. Notice that the sample is smaller than the whole, right? We're trying to understand all of the students, but we're just asking 100 juniors. We'll do one more. A medical laboratory counts the number of white blood cells in a drop of a patient's blood. The question being asked, or what they're trying to understand, is the number of white blood cells. That's what they would be counting. That's the question that they're asking. The population, again, is the whole, whereas a sample is just a piece or a part. We're trying to understand the white blood cells in all of the patient's blood, right? But it wouldn't be realistic to take all of their blood and sample all of their blood, right? We can't just remove all of the blood from somebody's body. So the piece or the part that we take is just a drop of blood. And we're just studying that drop, but then we would be able to make a conclusion about all of their blood based on that one drop. All right, the second thing we're going to take a look at is just some different types of graphs. So like I said, today we're going to look at bar graphs and circle graphs. So we'll go ahead and take a look at these two graphs. Now, a bar graph is used when one variable is what we call categorical. Categorical means occurs in categories or groups. So for example, a category would be your class, like freshman, sophomore, junior, senior. Or a category could be seasons, spring, summer, fall, winter. And the other variable is numerical. Meaning we should have a number representation. For example, how many students are in each class? So my categories would be freshman, sophomore, junior, senior. My number would be how many students. I could count how many students. So we can take a look at this graph here. We see that the bar graph shows the number of people. So we see here on our y-axis the number of people at a local YMCA who joined the volleyball and the basketball leagues. So we see a couple categories here. My dashes are volleyball, my solid are basketball. And we also see our categories here of years. So these years are split into two groups, volleyball and basketball. Year is split into two groups, volleyball and basketball. A says, in which years was the number of people who played volleyball larger than the number of people who played basketball? So we want to know when volleyball is larger than basketball. So when is the dashed line larger than the solid line? That would not be in 2014. That would be in 2015. That also happened in 2016. Not in 2017, and also happened in 2018. And not in 2019. B is how many people played basketball in 2018. So we could find 2018 and we could look at our basketball bar. Now, sometimes it can be hard to estimate. So if you kind of need to draw a line to compare those to help you think about where that's crossing, that would be about 350 people. And then C, how many total people signed up for volleyball or basketball in 2014. If we look at 2014, we want the total people. So I would want to think about my volleyball, which is about 200, and my basketball, which is about 350, and we would want to add those together to get our total. So that would be about 550 people. So we can see, I always say with stats, it's not necessarily hard math, but it's being able to look at graphs, understand, and interpret what is that graph actually showing us. All right, we'll take a look at our last type of graph. This is a circle graph, or also sometimes called a pie chart, because it kind of looks like pieces of a pie. A circle graph is going to be used when a categorical variable can be represented by percentages. So what we see here is we have some categories. We're looking at our favorite type of music. The circle graph shows the favorite type of music genres of students at Adams High School. So we see categories like rock and hip hop and jazz and country. And we see that those categories are given a percent. So what percent of the students prefer rock, or what percent prefer hip hop? A asks us which is the most popular type of music. Well, that would be the highest percentage. The highest percentage of students like hip hop. B says if there are 850 students at the school, how many students indicated country music as their favorite? So if we look at country music here, this 18 is a percent. It doesn't mean 18 students said they liked country. So what we would need to find is we would need to find 18% of 850. We can kind of use this reminder up here. What we're doing is we're trying to find a part of the students that like country music. That would be the percent times the total. So to find the students that like country, we could do the percent times the total. But we do want to be careful. We don't want to write 18% as 18%. We would actually want to write that as a decimal, which would be 0.18. And that we would multiply by the total. So this is my percent, and this is my total, and we are multiplying 850. That's going to be 153 students. And then last question, what percent of students prefer rock or jazz? So if we look at rock, rock is 27%. And if we look at jazz, jazz is 13%. And if we add those together, that would be 40%. Now it does ask us for a percent here, so that means we're good to just leave that 40%. We don't have to find the number of students like we did in B. So it's important to read carefully. Are we trying to find a percent, or are we trying to find the number of students?